Hello friends, in this video, we will discuss how to insert a new node to doubly linked list at the beginning. So here, the new node will be inserted at the beginning of a doubly linked list. And what is a doubly linked list and how is it different from singly linked list? Unlike singly linked list, we have two pointers priv and next in DLL. So after each operation, we have to maintain both these pointers. So here we have an example of a doubly linked list with elements 10, 20 and 30. If we insert 100, it will be inserted at the beginning and we will get the new doubly linked list as 100, 10, 20 and 30. Now let us see the algorithm to insert a new node at the beginning. So we will have two cases. The doubly linked list is empty and the doubly linked list has at least one node. So if it is empty, then the new node inserted will be the only node and it becomes the head node. And if it is not empty and it has at least one node, then the new node will be inserted before current head node and current head points to new node and make the new node the head. Now let us see the C program to insert a node at the beginning of a doubly linked list. So this is the function which will add the new node at the beginning of the doubly linked list. We will pass the value to be added to the function add first and it will create a new node with that value and insert at the beginning. So let us see how. So here first we have an empty doubly linked list. So head equal to null. Now let us insert a node with value 10. So we will call the function add first by passing 10. And let us see what happens. Here val will be equal to 10. So let us create the new node using malloc. So we have struct node star new node equal to malloc of size of struct node. So we have a new node created at address 1000. Now add the data to the data part. So write new node data equal to val. So 10 is added to the data part. Now we have to check if the doubly linked list is empty. And if it is empty, the new node will be the only node and it becomes the head. So check it and we got head equal to null. So we got the doubly linked list is empty. So the new node should be the head and it will be the only node, so its next and priv should point to null. So set new node next equal to null and new node priv equal to null. And finally we have to make it the head. So write head equal to new node. So head has the address 1000 and it points to this node now. So now we have the doubly linked list created with one node. Now let us insert another node with value 20. So first create the node using malloc. So node is created at address 2000 like this. Now add the value 20 at the data part. So write new node data equal to val. So 20 is added. Now check if DLL is empty. And if it is empty, head will be equal to null, but it is not. So go to else part. So if DLL is not empty, the new node should be inserted before current head. So set new node priv equal to null and new node next equal to head. That is 1000 will be stored in new node next and current head's priv should point to new node. So set head priv equal to new node. So 2000 stored in its priv. Now all the pointers are set correctly. Now new node should be the new head. So set head equal to new node. So head will now have the address 2000. Now let us insert another node with value 30. So first create the node using malloc. So node is created at address 3000 like this. Now add the value 30 at the data part. So write new node data equal to val and 30 is added in the data part of the new node. Now check if the doubly linked list is empty and it is not. So go to else part and the new node should be inserted before current head. So set new node priv equal to null, then new node next equal to head. That is 2000 will be stored in new node next, and current head's priv should point to the new node. So set head priv equal to new node. So 3000 will be stored in its priv. Now all the pointers are set correctly. Now the new node should be made the new head. So set head equal to new node. So head will now have the address 3000. So that is how we can insert nodes at the beginning of a doubly linked list. Now let us discuss about the time complexity. Since we know the position for the node to be inserted, that is, we have to insert at the beginning only. We only need to make some changes to the pointers, which will take only constant time. So the time complexity to insert a node at the beginning of a doubly linked list is order of 1.